Hi, Informs. This talk is 10 tactics for quantifying the decision scoring in a first-gen AI optimization system. My name's Steve Sashihara. My company is Princeton Consultants. We're a consulting firm, and our basic service lines are a full cycle optimization practice, a review of existing models, and help for building departments within organizations. Our basic insight is that innovation starts in the research lab, but our specialty is to help organizations deploy those great insights into what we call AI deployment. And our value proposition is we deliver high speed and quality and reduce risk. Toward the end of reducing risk, we've developed a series of risk factors that we help organizations understand score. We call the Princeton 20. And an example of this would be a typical first-gen AI optimization project. We would work with management and tag different risk factors that we think should be addressed to make the project as successful and as low risk as possible. For example, we might say, does this system replace an existing AI system? It's a risk because no system exists there today. Similarly, we may say, is there a way of scoring what is a successful decision, which is the purpose of today's talk? And they might say, actually, there's no really currently any scoring system that we use for making these decisions. We just use basically rules and people's intuition. So we might say, well, then it appears that there's not a real consensus around the rules. So that's a risk factor. And also, do we know that the actual decision being used to make the decisions, the data to use to make the decisions is completely available to us in real time on the computer, or are people using some head knowledge, emails, or other things? That might be a risk. So to capture this on one slide, here's a very common set of questions we might ask is there an existing optimization model in production? Factually, yes or no. So yes, if we observe it, do we see that they're actually, the field is using it, they're relying on it very heavily? Great. If not, there's a risk. There is a model in production, they don't use it that much, or they override constantly. Even worse, or higher risk is there is no existing model in production. However, in N1, there's a crisp objective function rules that we understand, but more commonly for us, there's no existing model and there are a fuzzy objective function or rules around the decision-making process. That's the purpose of today's talk. I don't think you find many N1 cases because for a large organization and importance of decisions, if you could have built a model easily and quickly, it probably would be there right now. So it's probably the reason they're doing it currently, without a model is because there's some challenges. It's a difficult problem. So one thing to say just to start is that often when someone takes a first generation problem, like for example, optimized job shop production, it really is a series of models that are working together. And the first thing you want to do is decompose the problem, start with one, and if you can get that solved, awesome, then move on to other adjacent problems or get deeper on the first problem. But even when you do that, for example, if you say a job's coming in, we want to see if there's a slot for on the schedule, and or do we, should we drop or shuffle other jobs off the schedule to make room for it, so-called optimal scheduling. Sometimes it looks like it's very easy in terms of the objective function. They say, pick the set of jobs which maximizes profits. But then very quickly you start to find, the objective function is a little bit more complex than was first presented or first thought of. For example, what maximizes the profits in the next 24 hours might not be the same answers that maximize over the next quarter. For example, if I'm presented with a job that is a repeating job, I should count all the different components, all the different instances of that job. And maybe I'm presented with a job that appears to be low profit, but it's because we've given a discount to that customer because they're a large customer and they give us lots of jobs. So we're not looking to optimize the next 24 hours. We're actually trying to optimize our profits over the next quarter or year. Also, we like to keep our promises. For example, we are willing to drop jobs off the schedule, but we really hate to do that because we said yes, and now we hate to call back and say no. Also, as you're evaluating what's a better and worse schedule, don't cut things too close. Just because the job is supposed to run for 45 minutes, don't make the next job start right after that. Put a little bit of padding in there so if something goes wrong, we don't have this domino effect. But on the other hand, don't over pad things because we want to keep utilization high. And also, particularly when we're undersold, distribute the workload, fairly among our different assets or jobs. You want to give all the work to one crew and the other crew doesn't have anything to do. And so I could go on and on, but given the short time, I just want to give an example. These are lots of the kinds of things that you get when you move to deployment. What initially seemed like a fairly easy problem, as you get to the real world schedule building, you get a lot of what we might call fuzzy objectives. So I'm going to give you 10 tactics for working through these. I'm sorry this is going to go so quickly, but this is the time for I've been given. So I'm just going to run through these 10 tactics very quickly. The first is start by working with the numbers that they are most comfortable with, which is the dollars. So the cost side of things and the revenue side of things. And often the problem has not been stated in a way that that talks about dollars, and that's actually a first win. For example, instead of minimizing miles, we might say, well, I get it. The more a driver costs, the more fuel they use, the more their time they use. But what if they stop at a place and they arrive early? Isn't there some time spent? You're paying the driver by the hour too, right? And they go, yeah, that's a good thought. Is that we should really talk about the driver cost, not merely about miles. So basically, get the dollars right, and then later you can proxy in some of the soft non-dollar costs. Secondly, make sure you nail feasibility before you start on optimizing. So don't assume the rules they gave you are ironclad. When you hear people say, oh, we never, or we never go over time, or we always start right when we say we're going to start. It's like, is that really true? So generate a wide selection of plans that basically show something just short of the limits they've given you or just exceed them, and see whether in fact what they told you are not hard constraints, but really soft constraints, or more precisely, their costs or bonuses in your objective. Third, people are not really oriented toward mathematical formulations generally, but they are oriented toward rules of thumb. So you basically extract rules of thumb from the training materials, from interviewing the subject matter experts, from watching how they work, by looking at the actual plans. You extract these rules of thumb, such as we always allow an extra 15 minutes. We generally assign senior tech to the big jobs. We try to minimize splitting jobs across shifts, and we really want to avoid splitting them overnight. And so you basically extract these rules, and that gives you your first step in. It's up to us now to come up with numbers, but at least we have a language of what they're trying to accomplish in a format that they can understand, which are basically the rules. The next step is basically to take what they have trouble quantifying and seeing if you can get them to tell you how they would deal with something. So you start with some wide variants that are extreme and then narrow it down. So for example, you may say, if a customer call with a last minute pickup, would you drive 50 miles for it? They might say, no, we're not gonna drive 50 miles for it. So, well, would you drive 1 mile for it? Well, sure, we drive 1 mile for it, not 50, but yeah, sure, 1 mile, that's not a lot of time. So you basically squeeze these toward you get to the tough calls. In tip 5, and then you ask them, what are some of the circumstances would change these values? For example, we got toward the middle where you're kind of iffy around the 5 mile area. What would make you say yes versus maybe not? They might say, well, who is it for? If it's a major customer or a new account, then we would certainly drive 5 miles for it, certainly longer. Or you might say, well, how busy are we? I mean, if we're really, really light, I drive 20 miles I mean, that's better than nothing. Or they might say, boy, if we're really busy, I'm not sure I would even be able to drive 5 or 10 miles because we'd clearly be dropping something else. So tip 5 is use different scenarios to see if you could extract what are some other variables that impact this cost or bonus. Tip 6, don't spend too much time exclusively working with plans. Actually get out and see what they actually execute. It's not the plan, it's what they do that drives the outcomes. And what if the plan is not taken very seriously? It's directional, but it's not necessarily gospel. And to guard against that, you really have to actually compare the plan versus the actual. So for in the case of a jobs scheduling Do the jobs run in the planned order, with the planned resources, for the planned duration, at the planned start and end times? So how does the actual compare against the plan? And the actual is where you're going to end up finding the real rules that they run by. Often the plan is a light version of the real set of rules. Um, uh, Now that you have some existing plans, try using your initial scoring system to see whether not say, hey, I scored 47.6 on this, but just take a couple plans and say, bring them back to your subject matter expert and say, hey, I've got plan A and plan B. They go, yeah, I understand these two. Now, how would you compare these two in terms of value for the company? So you might say, oh, A is way better than B, or A is slightly better than B, or it's hard to say. They both have their pluses and minuses. And so does that match ballpark with the scoring you've done? Before you get into the really esoteric stuff, are you in the right ballpark in terms of your initial scoring? So that's a tip. Sometimes it's really difficult to get started. It's hard to figure out um, uh, how simple to make the model, how complex. And so it's often easier if you can bring something from another industry, particularly if what you're doing for your application is somewhat of a first in your company or your industry. So you could say, hey, we're trying to do a job shop scheduling for a complex machine that there's no other people that make this, but I found another application where they're building cars, and like here, the jobs are also very complex. There's lots of sequencing involved. The duration of each step has a lot of variance, just like here. And they have different classes of labor. Certain people can only do certain tasks, just like here. And so basically, you bring in another industry and say, and all in, they got a lot of value. They've been using this for years. But here's the variables that they use. They don't go too far into it. They use ideal people. They don't use specific people when they're scheduling the labor, et cetera, et cetera. So that's tip number 8. Tip number 9 is a little bit of algorithmic. So there are a class of optimization technologies that can solve the problem hierarchically. So if you have a problem getting to agree on trade-offs between different things, maybe you can solve the problem hierarchically. For example, you might say, come up with a schedule that maximizes profits. Boom, do that. But now secondly, and let's say the maximal profit as the lowest cost, we've jammed all the jobs together. So as a second tier now, subject to that first function, reduce some of the shift overlaps. So maybe I started a job on the optimal schedule 15 minutes before the end of the shift. I'll let you slide that so that it starts on a shift boundary. Yes, that brings down the profits slightly, but I'll let the profits dip, say 2% to kind of get L2 done. And once you've gotten L2 done, then and only then you can spread the work among different work crews so that it balances out. But I don't want that to come at the cost of L1 or L2. That's hierarchical. And the last one I want to talk to you about is what we call smart options. Very enthusiastic about this, and I wish I could spend more time on it, but let me just say it very quickly. Smart options are an alternative to giving an optimal recommendation, a single optimal recommendation, but saying we're going to give them as different scenarios, meaning depending on the circumstances, we're actually going to give different answers. Not different data, different circumstances. We'll give multiple alternatives, not just one recommendation. They will be accurate because they're in very tight sync with the ground truth. They're in real time, meaning it's very helpful to give a user quick options and responsiveness. And they're thematically diverse, meaning not only am I going to give multiple alternatives, but they're going to be attractively different. To give you an example, consider you're in the Google search engine and you type a phrase. Depending on who it thinks you are based on prior queries, it may give you a completely different set of answers. For example, it appears from your prior search questions, you're very technical. Maybe I'll give you some very technical sites, or you're a general business reader. Maybe I'll give you some general ideas. There are multiple alternatives. I'm going to give you not just one site. I'm going to give you multiple sites. It's accurate in that I've recently searched these sites and these are good sites. I'm going to give you a fast answer in real time, and I'm going to give you that are thematically diverse. I wouldn't consider multiple options helpful if you gave me 5 options that are all basically pointing to the same site. So give me different kinds of sites. A similar example might be Amazon. I type in a screwdriver and it gives me multiple different possibilities, not just one, and also different classes. So yeah, those are smart options. Thanks for listening to our 10 items. And then my final picture is my view of optimization, which is it's hard, transformative at the same time. So thank you very much, and enjoy the rest of your conference.